Okay, Assalamu alaikum ya shabab. I hope you can all hear me. Let's see here. Yes, yeah, Hamid. You need anything?
لا خلاص دكتور، بس كنت بسأل إنه هل شابتر 6 إن شاء الله معانا لين 6.8، بس شفت العرض قبل شوي قلت يعني يمكن نخلص لين 6.8 اليوم يعني.
Hey, yes, today we will finish even more, okay? So don't worry about it. It's a very straightforward material, nothing more.
يعطيك العافية.
Okay, shabab, welcome back. Quick note. Okay, let me switch on the camera. Am I good? Okay. So, quick note, Juan. There are many students who send me email during the weekend. Some of them keep sending me reminders, okay? And I will check your emails today because honestly, from the number of emails I receive, if I just keep looking at them during the weekend one by one, I will not have a weekend. So I have to do it, inshallah, today. All right. I just posted an announcement about. Yes, Ali, do you want anything? I can't hear you, Ali. Can you please bring the mic closer to you? No, I cannot. Okay. So if you cannot attend for whatever reason, I will post the recording, inshallah. Okay. But this is the best I can do. So we'll have a help session tomorrow from 4 to 5:30 p.m. Our midterm is the day after, which is on Tuesday. The whole description about how are we going to conduct the exam is already published, posted in the Blackboard. I hope you have seen it. For the project, ya shabab, we shifted it to Tuesday, submitting the presentation until Tuesday, and next week, and then on Thursday we'll do whatever presentation. Okay. So I don't think we should talk about this now. Let's focus on this material first, and then making sure that you get ready for the midterm. Okay. Now we talked about fatigue in the last class, and as much as I can, I was trying, and I will always try to convince you that fatigue is a very sensitive damage, which means that to the extent, ya akhwan, that when we do fatigue testing, let's say you are my graduate student and we want to do experiment for your thesis. And if I am with you in the lab and you are holding the specimen for fatigue, and then the specimen fell on the ground, I will make a big deal. I will never allow you to mount the specimen on the machine and test it. I will ask you to go and make sure that you inspect it spot by spot under the microscope. And why? Because usually when we make specimen for fatigue testing, they almost look like mirrors. I mean, you can literally see your face reflection on the surface of the sample. Why is that? Why? Because we are trying as much as possible to rule the possibility that fatigue, which is very sensitive to any little tiny microscopic damage. So by accident, maybe when the specimen fell on the ground, it hit something. And then in the gauge section of the specimen, if there is a little tiny dent, just a little one, that's it, it's over. The crack will start from here, and this was a man-made. You made that damage, so it is not natural, and the sample does not reflect what is going on in real the material. Okay, we want it to fail under its own defect, under its own weakness, not by us. So remember this story because it's very important. We'll talk about it in a minute. So in order to study, طيب الحين يا شباب احنا عرفنا ان الفتيك هذا بلية مصيبة. Now how are we going to deal with it? How? The truth is, we could not have made automobile, cars without fatigue. And there is no doubt that the age of industrialized aircraft and aviation wouldn't have existed without fatigue. Without exaggeration. Without exaggeration. I am not exaggerating, Isha. I'm not exaggerating. Well, we developed design method based on, namely, 3 approaches. The first one is what we call the stress life approach. The second one is the strain life approach and the fracture mechanics approach. There is another one which is very much related to strain, which is called the energy approach. But in reality, it's under the strain life approach. So we're not going to talk about the strain life approach. We're not going to talk about fracture mechanics. I may tell you what it is, but we are going to focus on this, course on the stress life approach. What does stress life approach mean? We will talk about it in a minute. So in the fatigue regime, now, let me tell you what happened. In the stress life approach, you can imagine إنه أنا إيش راح أسوي? I will bring a specimen, okay? And such that I know the diameter here. So when I know the diameter, if I apply a force F on the specimen, I can divide it by the area. Area is related to the diameter, and I will get the stress. This is very simple. Now, the only thing I need is to buy a machine or design a machine which can, ya shabab, cycle the stress. So the stress, instead of applying a stress like this, like in the stress strain curve, I want the machine to apply the stress like this. So the stress like this, or sometimes we do it like this, it doesn't matter. Is it a triangular wave? This is called a triangular wave. Or is it a sinusoidal wave? It doesn't matter. What matters is that this stress is going up, down, up, down. Now, what would you expect? يعني يا أخوان, if I tell you this, and I tell you, إحنا طبعا يا شباب, I don't mean to complicate things for you, but if we have a waveform, how do we characterize it, ya shabab? How do we tell if this wave is different than this one or different than this one?
Wavelength, altitude, and these things.
Yeah, we use wave characteristics. Now, in our fatigue, it's very simple. We are going to characterize the amplitude, sigma A, and we are going to also characterize sigma mean. Of course, the tip over here is sigma maximum, and the one in the bottom is sigma minimum. Now, sigma minimum, not to be mistaken, it can be positive, it can be negative. In here, sigma maximum is positive and sigma minimum is positive. In here, sigma maximum and sigma minimum have opposite sign, which means that the negative stress goes to compression. So tension, compression, tension, compression. Let's agree. احنا ندري يا شباب انه المين ستريس هاي. We'll raise a question about how much is the mean stress. So it will complicate things. Let's make it simple. Let's make it a sinusoidal waveform such that sigma maximum is the same as the absolute value of sigma minimum. They are the same. If they are the same, the mean stress is here, is 0. And the amplitude is the only one which is going to decide how severe is the loading. Why? لأنه أنا بالإمكان أجي وأقول أنا بسوي amplitude صغير يا شباب. كم؟ 5 ميجا باسكال up minus 5 ميجا باسكال down. صح؟ I can do very big one. 100 megapascal and minus 100 megapascal. Now my question to you, if the y-axis in this curve is the stress amplitude اللي هو السيجما A, تتوقعون لما أنا أجي وأعمل application حق 100 megapascal of stress, where would be أنا وإيش راح أسوي؟ راح أخلي x axis. What is the x axis? The number of cycles. صح ولا لا؟ إحنا هذا اللي نبيه. تذكرون السيارة؟ نبي نعرف الكرانك شافت هذا لما يدور 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 آلاف المرات. كم مرة يتحمل؟ مليار؟ 100 مليون؟ 200 مليون؟ How much? So we are going to call this one number of cycles. So just without knowing, are we testing steel? Are we testing aluminum? Are we? If we have two cases where we applied a stress, let's say 50 megapascal. No, not 10, 50 and 100. أبغى أعرف يا شباب الآن I want to put a line on the in the x-axis. Where do you think the 100 will put a mark? طبعا لو حطينا 1 mark معناها the specimen failed. This is number of cycles to failure. يعني يا أخوان تذكرون سالفة العلاق حق الملابس؟ تذكرونه؟ If I tell you that you cycle the string up, down, each up, down is one cycle, 180 times. معناها إنك لو قدرت تحسب ستريس هنا بتقول هذه 180 ونفترض الستريس مقداره 60 ميجا باسكال، معناها النقطة هنا. This point in the curve represent a life relation with respect to a load. So for the 100, is it to the left or to the right? For the 50, is it to the left or to the right? Who's gonna answer?
For the 100 should be to the left.
Okay.
To the right.
And 50 to the right.
And 50 to the right. وانت يا فارس شو تقول؟
Do you hear me, دكتور?
Of course I hear you.
The point for 100 is before the point for 50 mega.
يعني معناها, if I understood you right, maybe 100 will fail here, but 50 will fail over here. Is that right?
Yes, that's what I mean.
ولا العكس, 100 هنا وال50 هنا. Blue or red? Red. So we will erase these 2 points. Now شو اللي صار؟ 2 point يا شباب تخدع صح ولا لا؟ الحين اللي في النص هنا هذا شنو هذا؟ straight line or curve like this or curve like this. It's very confusing. فايش نسوي؟ نجي نقول لك يا طالب يا باحث, you go make another specimen. مثلا specimen عند 60, and then logically it will be between the 150. So 60 might be over here. And then you just say, okay, let me make 80. And then 80 might be over here. And then 90. And then 90 might be over here. صح ولا لا؟ صح ولا لا يا أخوان؟ Is that right?
Yes.
Until you reach 100 and then you go here. Is that correct?
Yes.
Okay. Sultan, you want to say something?
No, doctor.
Okay. Now, my question to you. Is
دكتور يقطع
Your voice is breaking.
اي دكتور يقطع الصوت. دكتور ما نسمع.
this. احنا الآن my question to you before we understand better. If I yes.
We didn't hear the last thing you said.
Okay, I'm sorry. I was saying I am trying now. We are almost done with our curve, but what I want to do, you know, we are scientists and engineers, and so we always ask critical questions. So I'm gonna ask you a critical question. This one is where 100 fail. This is where 90, 80, 60, and this one is where 50 fail. My question to you, if I made another specimen for 100, where is it gonna fail?
Depend on the diameter.
شلون يا لا احنا لما نعمل تجربة يا اخوان نجيب عينة اوكي نقول للماشين شوب اللي شفتوها انتم في الكورس نقول لهم سوي لي 80 عينة exactly the same ما غير الجيومتري يا شباب. انا قاعد اقول لك جبت عينتين identical وبعدين حطيت عليهم سيجما A equals to 100. I want you to tell me أول نقطة failed here. نفترض عشان نعطيكم perspective حلو نفترض إنه هذا how much 1000 cycle وهذا مثلا 1100 وهذا 3000 وهذا 10000 وهذا 100,000 نفترض.
هذه الأرقام.
What is it?
نفس ايش يمثل؟
هذه number of cycles. كم مرة عملت اللود up down until it broke down.
اوكي.
اوكي احنا قلنا number of cycles to failure. ابى اسالكم سؤال. العينة الثانية حق ال100 انا برسمها باللون الاصفر. اللون الاصفر مفروض يكون on top هنا ولا هنا؟ يلا رقم 1 2 3 where؟
رقم 2 المفروض.
المفترض يعني كثيوريتيكال ايديلي المفترض 2 بس ممكن تختلف.
يعني ايش رايك يا حامد؟ تروح 2 1 ولا 3؟
اذا ثيوريتيكلي بقول 2 لكن اتوقع انها بتروح 3 انا.
طيب والباقي والشباب وش يقولون؟
اذا نفس السبيسمنت المفروض الثانيه بس الديفكتس حقها ما نقدر نتحكم فيها. ممكن يكون في فرق بسيط في العين.
صح. فايش اللي بيصير؟
حولها قبل ايه.
طيب وانت يا فارس بتقول شيء؟
I would say it's the same because it's same geometry, same specimen, same load.
طيب الحقيقة يا اخوان انه ماجد
we can't be sure is it 1 or 3 بس بتكون قريبة حيل يعني.
اوكي شوفوا يا شباب we would never be able to have it on top always. We cannot. الماتيريال احنا قلنا ان احنا ما نقدر نتحكم في طريقة الاورينتيشن حقت الاتومز when the atoms orient themselves in a way and then the material starts to solidify. There are always grains. The grains بحد ذاته يا شباب would never be identical for 2 samples. Although They are machined from the same material. They are made in the same factory. They are polished exactly the same way. You cannot. You have to understand that this uncertainty is always there. And you need to be very comfortable with it. لا تقعد تعاند. لا تصير ideal يا أخوان. Life is good with all of its deficiencies. You will know this later. It's always good. لولا الديسلوكيشن يا شباب ما قدرنا نعمل bending. ولولا if we cannot bend anything, how would we machine our tools? How? So it's sort of beautiful. Don't worry about it. The only matter is إنه إحنا لما نجي ونعمل testing for fatigue, you need to appreciate إنه there is always a statistical aspect there. So in reality, if I would want to draw a curve which mimics the reality, you will see data like this. They are in the same line because we test them at the same load, but unfortunately, depending on the material, السكاتر باند هذا ممكن يكون too wide. الورطة هنا وين يا أخوان؟ الورطة وين؟ لما يجي الديزاينر أنت بتصمم الطيارة، أوكي؟ أو سيارة. تخيل عندك possibility أنت تقول مثلا جاو the manufacturer and they told you the diameter must be 10. The load must be 100. So you calculated the stress and it turns out إنه هو 60. Now, are you gonna tell them the life is, 30,000 cycle? ولا بتقول لهم إنه life is nearly 15,000. ليه؟ لأنه أنت عندك possibility of failure. It can fail here, it can fail here, it can fail here, there. So, yeah, you may say that, this is it, you take the smallest one, but they will come back to you and tell you, no, find us any other way. What should we do? This is too much. If we make the stress based on this, the diameter must be increased. And if we increase the diameter, the machine will be too heavy, or it will be too expensive, or something like that. So the solution is not as easy as we think. But in general, ya shabab, this stress life curve is very, very famous. Very famous. When people first discovered that there is a curve, everybody on the globe started to fatigue testing. And let me tell you what happened. What happened is that they discovered that the curve in general tends to go, first of all, by the way, I'm gonna draw it in a straight lines, but in reality, the life here is log scale. كيف يعني log scale؟ يعني معناها إنه this is 10 to the power 0. كم؟ 1 cycle. Do you know what does 1 cycle mean? يعني معناها إنه اللود كان مرة عالي قبل ما أنت تعمل cycling. You cycle up, down, you reach here sigma ultimate وانكسرت العينة. حتى قبل ما تكمل يعني معناها وأنت تعمل load up ما بعد تنزل انكسرت العينة هنا. That's 1 cycle. And then they discovered that by changing the stress by tiny little bit, the life might go from 1 cycle to 3,000. And then you drop it a little bit from 10,000 to 100,000. And then you change it a little bit from 100,000 to 1 million. From 1 million to 10 million. What is this? This is a log scale, a logarithmic scale. عشان كذا اول درس تعلموه في الفتيك انه it is logarithmic in nature. So this is 10 to the power 0, this is 10 to the power 1, this is 10 to the power 2, this is 10 to the power 3, 10 to the power 3 1000. بعدين 10 to the power 4 10000. 10 to the power 5 100,000 100,000. 10 to the power 6 1 million. 10 to the power 7 how much? 10 million. 10 to the power 8 100 million cycle. Now in general يا اخوان انا ابغاكم شباب الحين انتم تفهمون في السايكل صح؟ انت لما تيجي تشد اب داون كم محتاج 1 سايكل صح؟ 1 second 1 second almost 1 second يمكن اقل من السكند بشويه عشان لا تتعب نفسك بالكسور. انا بسالكم سؤال كل واحد يشغل الكالكوليتر حق جواله الان you know turn on your calculator on the mobile. If I tell you that this ruler I can cycle it like this for 10 to the power 8 you know no لا نخليها 10 to the power 8 1 million cycle 10 to the power 6 1 million cycle. ابغاك انت تروح في البيت وتسوي 1 million cycle. Each cycle is in 1 second. كم تحتاج؟ حسبوها. مليون يا شباب مليون احسب مليون تقسيم كم؟
4.6 days.
How many?
4.6 days.
Okay, I'm gonna take your word. 4.6 days.
No. Wait. 11.5. 11.5.
Okay.
11.57 days.
Okay. هذا 1 مليون صح؟
Yeah.
10 مليون كم تصير؟
مية وخمسطاش 115.7
100 مليون 100 مليون
1157.
Yeah. So 1157 is nearly how many years?
4
nearly
years.
3 years. Yeah, nearly 3 years. Can you imagine? Now, when you do it with hand, it's very slow. If I tell you that there are machines that operate with the turbines, they have a 10,000 RPM or 20,000 RPM. If you divide this, and then you get how many cycle per second, you will see how many cycle you can burn in 1 day. Do you understand? So in general, what has been discovered is that this curve, طبعا يا شباب, if we plot it, it turns out that the relation in fatigue is exponential, in the sense that is a power type. يعني sigma equal to a constant A multiplied by the x-axis هو life. We will call it number of cycle to failure, NF, to the power B. If you represent sigma A and F as a curve, طبعا ال A is a constant while B is an exponent. If you represent this relation in a log scale, what will happen? The power law will become a straight line, right? And then what happened? What has been discovered is that there is a little tiny straight line. After that, there is a very big one, different slope. And then there is a point which seems to be a very special point. What is this point? This point, نجي وناخذ عينة, okay? And then we load it with sigma A equals to 1 megapascal. شباب 1 ميجا باسكال على steel is nothing. Is nothing. So 1 megapascal is here. 100 million, 200 million, 300 million. اول حاجه يا شباب انا بقول لكم شيء، اذا في طالب، انت طالب تبي تصير دكتور، طالب دكتوراه، تدرون انتم في العاده يعني عاده عشان تصير دكتور كم تحتاج تدرس؟ البي اتش دي نفسها ما بين 3 إلى 5 سنوات. طيب احنا الحين قلنا ان 100 مليون لو تسوي السايكل 1 بير سكند يحتاج لك 3 سنوات. متى تتخرج انت؟ ومو بس كذا، مو بس كذا، انت تخيل قاعد تشتغل 3 سنين على عينه واحده. ها، والسكاتر احنا ايش قلنا؟ قلنا لازم تعيدها على الاقل 3 مرات. طيب وبقايا الكيرف متى تخلصه؟ متى تخرجك انت؟ And this is where it becomes a problem. So what people do, they say, okay, let me try to go to maybe 10 million. أنا يا شباب, I'm a fatigue guy. I did my PhD on fatigue. And I spent 1 month running after a test. I had to walk on the snow every night to go and check the specimen. It didn't fail. And then I go home. And then I go back. And then I go home. And then I go back. And then I go home. When it reached 10 to the power 7, it didn't fail, which is how much? 10 million cycles. Of course, I was increasing the frequency. I cannot do one cycle per second. I have to multiply it by 10, 20, and there is limitation. I can't make it 1,000. The machine will break down. So I think I was doing it at 15 or 10 hertz, something like that. And it didn't fail. So when it didn't fail, okay, what did we do? We put the stress, which I applied, and then we put a buoyant, and then we draw an arrow like this. What does this mean? هذا نسميه يا شباب run out. What run out mean? خدعة تخلينا نتخرج يعني وش نسوي؟ You know what does it mean? If you go and check the fatigue curve, all fatigue curves, you will see buoyants here with arrows. This means they tested the specimen at this stress, it did not fail, and they stopped the test. They can't keep running it, ya shabab. But it didn't fail. Now, how are you going to make a decision? I don't know. However, of course I know, but I'm not going to talk about it today. So what happened is this. This line, it was discovered that there is a line where data start below it, below this line, this area, below this line, okay, there is no failure. There is no failure. What does that mean? There is no failure within our practical life. You understand? Within our practical life. So, اللي صار يا أخوان بأنهم قالوا بأنه هذا اللاين سموه endurance limit. What does endurance limit mean? It means if you are lucky and you can design your machine below this line, theoretically your machine will never fail. ليه؟ لأنه مهما سويت إحنا يا شباب, when we put a line like this, if I tell you the stress is this much, you will tell me the life is this much. If the line is here and then I go and I draw a line here, there is no failure. Does this exist? No. No. Theoretically, it exists. Practically, people believe that this requires hundreds of millions of cycles. That's why they call it the endurance limit. Endurance يا شباب باللغة الإنجليزية معناها لياقة. You know?
Doctor?
Yes.
Is it a straight line with zero slope, or it has a negative?
That's a very good question. What people discover إنه the curve goes like this, and then it tends to be straight almost, then it drop, then straight, then it drop. طبعا الآن الحياة تطورت. Today there are machines that can apply gigahertz. Do you know what a gigahertz? It's like several millions per second. That is so fast. And this is when they discover that if you actually test long, you will see that there is going to be a failure. But it is at hundreds of billions of cycles. Now, you will tell me, why should we care? أنا بقول لكم حاجة يا شباب. You know the hyperloop صح؟ السعودية ناوية تسوي hyperloop.
Yes.
hyperloop يربط المملكة. hyperloop يا شباب. One day, maybe your kids, okay, will have a job in Europe. زي ما يطلعون من الشرقية بالقطار إلى الرياض، ابنك حيطلع من الرياض إلى فرنسا بالهايبرلوب. الرحلة ممكن تأخذ لها 3-4 ساعات. Do you understand? And because it is too fast, okay, anything that rotates within the hyperloop, anything that moves within that speed will burn millions and millions of cycles a second. And this is why this field, which is called the very high cycle fatigue, become very important in the future. This is my prediction. Now, we need to move on. Yes.
دكتور بس السرعة لما تسوي مثلا up and down راح يأثر أكثر لما أنت بس كذا بشويش تسوي up and down.
يعتمد. لا اي صحيح. شوف هذا اللي يسموه الفريكونسي افكت. In general يا اخوان up and down between 1 to 100 hertz. In general في الميتالز، انا اتكلم عن ميتالز، ما في فرق. يعني سواء سويت بطيء ولا الى 100 سايكل بير سكند ما يطلع فرق. But it has been proven that some materials, polymers وغيرها, and even metals, if you go very, very high cycle fatigue, then you might get dependence on the cycling. So you need to take that into account. Okay? Of course, يا شباب, the loading, when you cycle, you need to be very careful. The loading has to be very little tiny compared to the yielding. Why? Because if you do like the string, this is the story I told you before, if you subject the specimen to very high stressing with too fast frequency, it will burn. It will become very, very hot. So if you go to very high load, you need to make it slow. If you go to small load, you can make it fast. عشان السبيسمن ما يصير له heating. Now, how did we manage so far to understand the relation in fatigue? Well, the most famous test is called the rotating bending test. The rotating bending test has a very nice characteristic, يا أخوان. If you apply 4-point bending, what will happen? اللي بيصير إنه in between the forces, as you see, you will have no shear and you will have pure bending in the middle. So all what you need to do is to design the sample such that the gauge, which is this one, see the gauge, is in between these two forces. So what happened? You will have a pure bending state. Sigma equals to MC over I. There is no shear. لأنه إحنا لما نعمل testing, we don't mix things up. We don't want to do shear and bending.
Can you repeat, Doctor? I didn't get it.
Okay. إحنا لما نجي نبي نعمل testing يا أخوان, we want to characterize the fatigue behavior of the material under normal loading, which is tension compression. So one way to do it, which was very easy 100 years ago, was to do it under 4-point bendings. ليه؟ لانه الفور بوينت بندنج الماشين هذه مربوطه بموتور، واذا جيت انت علقت العينه هنا، مسكت العينه من هنا ومسكت العينه من هنا، هنا الموتور روتيت very fast. الموتور can rotate 1000 cycle per second. Then all what you need to do is to apply 4-point bending. Load like this and load like this. If you apply 4-point bending while the specimen is rotating, you are actually applying the load up and down. But you don't want to apply the load بحيث انه you have two modes, shear and normal. You want it to be done at uniaxial state. So 4-point bending is so special because it can give you this characteristic. The 4-point bending, at this side you have shear and you have bending. At this side you have shear and you have bending. But in this side you have zero shear and you only have maximum bending. That's why we love 4-point bending. We can test the material under pure bending loading, and we can run it fast so we can generate curve. We can do cyclic tension. Cyclic tension compression will do only tensile loading and compressive, and it will not involve any shear. But this type of machine wasn't invented يا شباب إلا في الليت، يعني في 1950 و60. قبلها كانت المشهورة هي ال 4-point bending. طبعا both machine exist and we still use them. This is a representative curve. We spent good time explaining it. So in general, up to 10 to the power 3 cycles, we call this low cycle fatigue. Why low cycle fatigue? Because the number of cycles is too low. Yes يا فارس.
دكتور الحين التنشن ماشين هذه اللي قبل شوي وحقة الكمبريشن كيف نعرف إذا كم سايكل؟ يعني
هي الماشين تحسبها.
هي الماشين.
هي الماشين فيها سنسر، وكل ما الماشين صعدت فوق وتحت تحسب 1 سايكل 2 سايكل 3
لو مثلا سبيسمن انا قاعد اسويه بيدي، يعني التنشن قاعد اسوي عليه فورس بيدي، كيف بعرف انه كم سايكل؟
لا يو دونت. الماشين هذه كمبيوتر كنترول، تقول لها run the amplitude و run the mean و run and it will run until the specimen fail. وتقول لك تقدر تروح بيتك وتنام، تجلس الصبح وتجي وتشوف العينة انكسرت والماشين بتقول لك how many cycles. Okay?
Thank you.
Okay. بعدين after 1000 cycle we call it high cycle fatigue. This is mostly high cycle fatigue where all equipment operate. And of course these are the runouts. The runouts are the tests that did not fail. Okay? Now in general, different materials behave differently. So those are called the route alloys. طبعا يا شباب كل ما صعد الكيرف كل ما صارت الماتيريال أقوى بالنسبة للفتيك. لو تلاحظون الساند كاستنج تحت. ليه؟ لأنه مصيبة الساند كاستنج يا شباب إنه زي ما علموكم في المانيفاكتشرينج it is always prone to develop bores, little holes. And those little holes are not a friend with fatigue. So casting are usually here while route are there. What are route? Rolling, extrusion, forging. So you will always see extruded, forged material used. For example, أنا قلت لكم إنه الكرانك شافت في السيارة مصنوع من forged material, not from casted material. And this is the reason. Now, احنا الآن أهم حاجة بالنسبة لنا إن احنا نعرف لو فعلا عملنا تيست وصارت الانديورنس ليميت هنا، شايفين؟ هذه الليميت اللي تحتها ما يصير فيلير. طبعا للمعلومية يا أخوان، الآن الساينتفك كوميونيتي حقت الفتيك حرمت نطق كلمة endurance limit، لكن للأسف الكتاب لسه قاعد يستخدمها، لأنه زي ما أنا شرحت لكم الاكتشاف الآن إنه there is no endurance limit. There isn't. So the endurance limit is a false value, but راح نستعملها في الكتاب. الendurance limit يا شباب we will call it SE prime. ليه SE prime؟ لأنه later we will teach you that there is SE without a prime. What does this mean? The difference between the two إنه هذه uncorrected endurance limit بينما هذه اسمها fully corrected endurance limit. شو السالفة؟ بعد ما الفتيك people discovered a relation, they started to do fatigue everywhere. And because steel was the most important metal in the world, so what happened? They discovered that this steel, we want to know its endurance limit, but we don't want to do the test. So they realized that the endurance limit is equal to, the uncorrected endurance limit is equal to half SUT. Half SUT, نص ultimate strength. إذا كانت الماتيريال عندها SUT which is 200 kbsi اللي هو أقل أو equal, less than or equal 1400 megapascal. If the material has an ultimate strength which is greater than 200 kbsi اللي هو greater than 1400 megapascal, then the endurance limit in kbsi is 100 and in megapascal 700. So الendurance limit يا شباب اما تكون 700 ميجا باسكال اوكي او ان هي تكون what تكون 0.5 ultimate stress. Do you understand? Now there is one point which is about how do we model the curve. This curve which look like this. طبعا البداية ما هي مهمة كثير. ليه؟ لأنه البداية يا شباب فيها 1000 سايكل. 1000 سايكل هذه تحرقها ببايك لما تطلع من البيت إلى البقالة. It's very easy. And after the endurance limit, you have an infinite life, theoretically. So the focus is between 10 to the power 3 and 10 to the power 6. This is when you have finite life. Do you know what's a finite life? So, a finite life means if you have a stress here, you want to know how many cycles do you have for whatever reason. Do you understand? So, I'm going to show you the equation. The equation is this. We have 2 minutes. I might, ya shabab, add a little 10 minutes video because this is part of the exam. So I will just explain the derivation. I mean, you will not be asked to derive the equation in the exam, but I will add it just for comfort. Otherwise, you know now everything. So how do we find the relation? Is this? This is SF, the fatigue strength, equals to AN to the power B. What is A? A is a constant and B is an exponent. To find A, you need to take F. F is a constant, another one which usually F is equals to 0.8. This F is either given to you or you can calculate it from another equation. I will show it to you. And then you multiply it by SUT, then you square it, and then you divide it by SE. Okay? SE is the fully corrected endurance limit. الحين تقول لي طيب احنا ما نعرف الا SE prime. Don't worry about it. We will talk about how to correct it later. And then B equals to minus 1/3, the log of F again multiplied by SUT divided by SE. Now, look what happened. If you have a problem and I told you if you apply a stress sigma A, which is completely reversed. إيش معنى completely reversed? Because I told you from the beginning that we are not going to talk about mean stress. So completely reversed mean, sigma mean is equals to 0. Okay? We will stick with this. Later, we will show you how to deal with condition when the mean stress is not equals to 0. But if you know the stress and you know A and you know B from this equation, okay, you can actually find the number of cycles. So all what you need to do is to tell me, مثلا, sigma is 100 megapascal divided by A to the power 1 over B. And then you will find the number of cycles. What is the number of cycles? 100,000, 200,000, 300,000, I don't know. The only note I would like to tell you is that this equation is valid between 1,000 cycle to 1 million cycle. اللي هي 10 to the power 3 to 10 to the power 6. Why? As I told you, the assumption إنه the endurance limit will start after 10 to the power 6 and between 10 to the power 3 and 1 cycle, okay, 10 to the power 0, there are only 1,000 cycles. So we don't usually design there. Okay, أخوان? So what I'm going to do, I will add a video today, okay, in addition to this one, to further, you know, go over the derivation and makes you feel comfortable about the relation. But this is the equation, and maybe I will solve even few examples for you if you need them, okay? Thank you so much, ya akhwan.